Welcome to the third section. In this section, we will cover more advanced Java concepts and will touch on topics such as untyped versus typed data structures, trying to understand the difference and applicability, various collections including lists, sets, and maps, static methods and static variables, and instance methods. Now, let's proceed with the first video of this section. In this video, we are going to take a look at Java collections, and specifically at comparing arrays with lists. We will also look into typed and untyped lists and try to understand what is the difference. Then, finally, we will try to apply this knowledge by improving our application's implementation by adding lists. Now, we have to answer a question. What is a list and what is an array? Let's start with the simpler one. An array is a collection of multiple elements, usually of the same type. It's fairly simple in functionality, and it is able to store data and provide it back. Lists aren't too different. They too are a collection of one or more elements, usually of the same type. However, since in Java, the implementation of lists is a proper class, unlike the array, lists provide a rich API with methods that can simplify our interaction with the set collection. Also, list implementations provide another core feature which is missing from arrays. They do not have a set size. Once an array is initialized, it will retain its initial size forever. A list, however, grows dynamically by adding blocks of empty space ahead of the current number of elements. While both perform a very similar job, there are some key differences that can make the developer pick one or the other, depending on the technical requirements. Luckily, performance is not one of those differences, since in Java, ArrayList, which is an implementation of a list, is based on arrays, and both of them provide the same level of performance. To give you some context, at the bottom of this slide, there are two columns. In each of them, you can see the declaration of a list and of an array, and the addition of one element. As we have mentioned before, once an array list, or any kind of list, is created, it dynamically adjusts its space internally, so it can cope with any number of values. An array, however, has to be declared with a precise size that it can grow to, which in our case is 1. If you have added a second element to the array list, everything would go fine. However, if you attempted the same operation on the array, you would get what's called an array out of bounds exception, since you will be trying to access memory location which has not been assigned to the given array. As we've mentioned, the Java list is an object, an interface, and all its implementations are normal Java classes. Let's now go through the main implementations of the list interface. The first one, which tends to be the most popular, is ArrayList. This is based on arrays, which means it's quite fast when iterating over it. The next example is Linkedlist, and unlike the previous one, a linked list is not based on arrays. However, it stores each value in a bucket and creates a pointer from the current bucket to the next element in the list. Since those pointers can be moved around quite easily and quickly, this particular implementation is the most efficient one when adding or removing elements inside the list. We've included the next two collections in order to create a more complete list. However, we will not use either vector nor stack. These ones are quite old. They were present in the first version of Java, JDK 1.0. and have only been developed a little since the Java collection framework was launched. ArrayList is a better replacement for vector, and Linkedlist is an alternative for stack. Both alternatives are quicker, especially when multi-threading, and more memory efficient. If the collections in Java are not enough for your use case, you should know that there are several collections libraries available for free in the open source community. One of them, and perhaps the most well-known, is Google Guava, which contains immutable versions of most collections. Alternatively, Eclipse Collections is also a strong candidate and is more appropriate for high-performance applications, since the project was initially developed to serve investment banking applications. If we were to describe graphically how the main two lists implementations work, those being ArrayList and Linkedlist, the diagram would look like this. As we've mentioned before, the ArrayList implementation is based on arrays, so access is based on the location of each value, also called index. You can find the first value by accessing the cell with the index 0, the second value in the cell with the index 1, and so on. The key advantage of this implementation is that iterating through an array list is as fast as doing it over an array. A linked list, however, while to the developer it may look similar to an array list, since the class implements the same list interface, differs in the actual code implementation. Each value is stored in what we can call a bucket. Each bucket has two elements, one cell for the actual value, and the second cell that is pointing towards the next bucket. The obvious advantage of this implementation is adding and removing random elements. While in array lists, adding an element in the middle of the list would require at least a full iteration, in a linked list it all comes down to changing the pointers to reflect the new order. No other operation is needed. Now we will touch on a really important topic that you will not only use with lists or collections, but as a generic practice in Java. When supported, typing an object usually refers to specifying what kind of arguments should the set object accept. Let's think of a list. As we have already described, this is a collection of elements. It can be any elements, and to avoid unwanted types going into the collection, we have to specify the type. In the example in the left column, we have typed the list with the type string. This means that the list only accepts strings, and the program does not compile otherwise. In the right column, we have provided an example that uses an untyped list. This means that we are able to insert any type of object in the list. If we are to compare the later parts of both columns, we can easily spot how we can run into problems with untyped collections. While not using types gives us full flexibility, as with any such powers comes great responsibility. In our case, the responsibility of making sure what kind of objects we insert into the collection. For the typed array list, the problem will be easy to spot in any IDE. Trying to insert a value of another type, in our case, inserting an integer in a list that is of type string, will be highlighted by the compiler. There is no chance that the application runs. In the right column, we are attempting to do the same, adding values of different types and succeeding. That is intentional. The issue appears when the developer retrieves the object and has to make assumptions over the type. In the last line, we are making an assumption, or in Java terms, casting the variable to a string, and then call a method that is specific to strings, split. Called on a string, this is supposed to split it after every space. However, in our case, a.get1 will return a number. A number cannot be cast to a string, so the line will throw an exception. Now, let's have a look again at our application diagram. By now, you should already be familiar with this. We won't go again through the elements. However, we should highlight something that can drastically improve now with the newly acquired concept of lists. We are now able to store more than one song per album and more than one album per artist. So the new diagram changed a little bit and should look like this now. It sounds more natural now that the artist object is able to be linked to many albums, and an album object can be linked to many songs. This is equivalent to saying that an artist released many albums, each of them having many songs. Finally, the listener object is now storing references to multiple songs that have been listened to, so we will be able to find out how many songs has the listened to and who's the most music avid fan in our database. Now it's worth mentioning that as we learn more programming concepts, we will revise our list of requirements in order to improve the application by leveraging all these new features that Java offers. Now that we know how to use lists, we are able to answer more complex questions using our application, such as retrieving all albums released by a given artist, getting all the songs on a given album, finding out how many people listened to a given song, or how many songs has a given person listened to. The change that we have to make is pretty straightforward. We need to allow multiple songs to be part of an album, multiple albums to be released by an artist, and multiple songs to be listened by a listener. Let's go ahead and change the album first. Remember, our song field is defined in abstract album, while the getter and setter methods are defined on the album interface. Let's first change the field type from song to list of songs. Now IntelliJ will report errors. This is expected since the field is now a list, but the getter and setter expect a song object. Let's now go to the album interface and change the type. You can do this in the IDE by right-clicking on the getter method name and under the refactor menu, click Change Signature. Then change the return type to list of songs. Now, this is a trick and comes with experience of working with lists. The code calling these methods will likely expect to add one song at a time, not to set the entire list at the same time. In order to change this functionality, we have to do three things. First, let's change the setSong method name to addSong on the interface. Then, let's change the implementation in abstract album. Finally, let's add the default value to song list in abstract album to make sure every object starts with an empty list. Once this is done, let's do the same for albums under artists. That will include changing the methods on the artist interface, then changing the code in both band and single artist. Don't forget to give a default value, or in Java terms, initialize the albums variable in each of band and single artist. Finally, let's change the listener class as well. This should be a bit simpler since it only involves changing the type of the listened to song variable and the getter and setter methods in the same class. If we now go to My App, we will see some syntax errors. This is expected since some of the method names changed. We will notice that we need to make a few more changes to the album interface and abstract album class in order to expose methods around retrieving songs and getting a certain song in an album. Let's make those changes to fix the code. That's all for the current video.